In this lesson, we will be learning about compound inequalities. So to make an inequality compound, it means when there are two inequalities that are joined by the words and or the words or, okay? So you can write an inequality involving and. You can say x is greater than or equal to -5 and x is less than or equal to 7. Okay, you can also write it where the x is in the middle and you read the x first. Okay, so x is greater than or equal to -5 and it's also less than or equal to 7. Okay, so we're saying that it's in between. Okay, so when we're talking about and, we mean in between. Okay, so if you look at this example here, this first line represents x is greater than or equal to -5. This line here represents x is less than or equal to -7. So then we're talking about, well, where's the in-between part? Where do they intersect? Well, between -5 and 7. Okay, so x is any number in between here. Okay, so let's do an example. So if we want to write a compound inequality that represents each situation, okay, so all numbers that are at least -2, okay, so x has to be greater than or equal to -2, it has to be at least -2, and at most 4, okay, so the most it could be is 4, okay, so we could write it like this, x is greater than or equal to -2 and x is less than or equal to 4, or we can have x in the center. I know it's less than or equal to 4, and it's greater than or equal to -2. Okay, so I'm going to find -2. We know it's greater. And 4, we know it's less. So all of these numbers in between can be the value of x. Okay, the next one. Today's temperature will be above 32 degrees, but not as high as 40. Okay, so x is going to be above 32, so it's greater than 32, and it's not going to be as high as 40, so it's less than 40. Okay, so again, remember that we can write this in another way where x is in the center. So x is less than 4, okay, but it's also greater than 32. Okay, so if I draw my points, I'm sorry, not 4, 40. Sorry about that. Okay, so I'm just going to label this one 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay, it's greater than 32, but less than 40. So I'm in between here. Okay, so for the next example, these are problems that you might see in your book. Okay, so let's go ahead and look at the first one. If we want to solve for r, okay, so here I have -4 is less than r minus 5, which is less than or equal to -1. Okay, so we're going to kind of think about this as like, how do we solve for r? Okay, so there's two ways. One way is if I add 5, if we think of it as we just like cut off the left side first, and we're just talking about here, we're going to add 5 and add 5. Okay, that's what we would normally do in an equation, but because we have 3 parts here, we're going to add 5 to everything. Okay, so now I have 1 is less than, this becomes 0, r, which is less than or equal to 4. Okay, so now I'm done here, so I can leave it written as this. Okay, another way if you think it's confusing is to separate. So you could start out with -4 is less than r minus 5, okay? And then you could make the other equation as, the other inequality as r minus 5 is less than or equal to -1, okay? So technically here you're doing the same thing. To get r alone, I need to add 5 to both sides. So I'm going to get r is less than 1. Okay, and over here if I add 5 to both sides, I'm going to get this was r is greater than 1. R is less than or equal to 4. Okay? So again, I get the same thing, but in this way I just write the word and up in this one, it's all together. Okay, so why don't you take a minute and try these on your own and then check back. Okay, so let's take a look at the first one. Okay, so I see that I need to get x alone, so I would normally divide by 3, so I'm going to do it everywhere. So negative 2 is less than, is less than x, which is less than 5. Okay, so in order to graph this, I need to have 1, 2, 3, 4, 5, 1, 2. Okay, so x here, if I'm reading it, is greater than negative 2, greater than or equal to negative 2, okay, and it's less than 5. So greater than or equal to 2, less than 5. So everything in between. Whenever we're working with an and, your graph will always look like this. It's going to be something in between. Okay, the next one. Okay, so for everything here, I'm going to first add 1. I'm going to go ahead and rewrite this to make it a little bit bigger. So if I add 1 first to every side, okay, it becomes, because I want to balance everything here, so it becomes negative 2, which is less than 2x. This becomes 0, which is less than 8. Okay, next step, to get x alone, divide by 2, so I'm going to do it everywhere. So now I have negative 1 is less than x, which is less than 4. Okay, so to graph this, I need to have the points 1, 2, 3, 4. Okay, so x, I'm reading it starting from x, x is greater than negative 1, which would be going this way, and x is less than 4, should be going this way. And again, they happen to be in the center. Okay, so the next part that we're talking about is inequalities containing the word or. So this could be one or the other. Okay, so these situations represent or. So all numbers that are less than negative 3, so x is less than negative 3, or the numbers could be greater than 7. Okay, so there's only one way to write these, and this is how it would be. So if this was 0, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, negative 3. Okay, so x is less than negative 3. Less than negative 3 is going this way, so it could be all these numbers, or it could be x is greater than 7. Okay, so notice that they're two separate quantities. Okay, so looking at the next one. Discounted fares are available to children 12 and under. Okay, so if you are 12 or under, so you could be 12 or less than 12, you get a discount. And then here's the key word, or you're an adult and you're at least 60. So you are 60 or older. Okay, so here we can see that you get a discount if you're 12 or younger, or 60 or older. Okay, so here, if we want to write in, we don't have enough room here, so I'm going to write 60 and 12. Okay, so if I am less than or equal to 12, so it's included, I get a discount. So any age less than 12. And if I'm 60 or older, I get a discount, so any age older than 60. Okay, so let's try a couple of problems where we're solving for x. Okay, so in the first one I have 4v plus 3 is less than negative 5. Okay, so to solve, I'm going to subtract 3 from both sides. So 4v is less than negative 8. If I divide by 4, I get that x is less than negative 2. Okay, so that's one part. Or, if I solve my second equation, negative 2v plus 7 is less than 1. Okay, so I'm going to subtract 7 from both sides. And here I get negative 2v is less than negative 6. So dividing by negative 2. Here I'm dividing by a negative number, so remember that this has to flip. So I have v is greater than 3. Okay, so or v is greater than 3. Okay, so now graphing them both on the same line. 0, 1, 2, 3, and negative 2. Okay, so v is greater than 3, so I'm not including it. It's an open circle to the right. It's greater than 3. Or it's less than 2. Okay, so take a minute and pause the video and try these next two on your own. Okay, so for the first one, if you solve for b, you will get, if you add 1 to both sides, 3b is less than negative 6. Divide by 3, so b is less than negative 2. Okay? Or you have 4b plus 1 is greater than or equal to 9. So I subtract 1 from both sides. 4b is greater than or equal to 8. To get b alone, divide by 4, so b is greater than or equal to 2. Okay, so here I have b is less than negative 2 and greater than or equal to negative 2. Okay, so this might look a little bit weird because 1, 2. Oh, no, it's okay. All right, so b is greater than or equal to 2. So here's 2. Filling it in, it's greater than or equal. Okay, b is less than negative 2. It's an open circle. It's not included. Less than negative 2. It's going this way. Okay, and moving on to the next one. Here I have to solve for y. So subtract 7. 5y is less than or equal to negative 10. Divide by 5. Y is less than or equal to negative 2. Okay, or if I add 2 to both sides, 3y is greater than or equal to 15. Divide by 3. Y is greater than or equal to 5. Okay, so if I want to graph this point, just use this right here as my line. So 0, 1, 2, 3, 4, 5, and negative 2. Okay, so y is less than or equal to negative 2. It's included. Less than or equal is going to the left. And y is greater than or equal to 5. It's including 5, and it's greater than or equal to 5. And that's it. So just notice that you see that all of these here, the ors, the graph looks, sorry, let me write it down here. So in all of the ors, the graph looks something like this, where they're separate. Okay, so you may also graph something with an or that could look like two lines on top of each other. So for example, maybe one is going this way, and the other one is here going in the same exact way. Okay, that's possible. And then your graph is always going to be in between. So you have something here, and you're in between because it's and.